This is my project on physics behind diagnostic imaging. So my purpose is to discover MRI and CT scans as medical imaging devices and understand more of the physics behind them, and also to see if MRIs or CT scans has a better diagnostic tool than each other. So the sociocultural impact medical innovation is forever improving with research and different discoveries through scientists. It is important to know that and understand these discoveries and keep up to date with things like MRIs and CT scans to accurately diagnose patients and improve treatment plans. As a future PA, I'll be using these tools to treat patients, and it is important to know where they came from, how they work, so that I can better diagnose my patients. MRIs use magnetic fields and radio waves to create images of other tissues and internal structures like white and gray matter, aneurysms, and tumors in the CNS system. Then you have CT scans that detect very similar things just using X-rays. They can also look into heart disease, kidney stones, and cancers. This is my model on MRIs. In the center image here, you can see an actual MRI machine broken down. So the magnet is a superconducting magnet that creates a magnetic field. Gradient coils then specify and change the frequency of that magnetic field for each part of the body. And finally, the RF coils interact with the hydrogen atoms to create a better imaging resonance, like shown in the bottom left-hand corner. The bottom right-hand corner, I used our physics models that we learned in class to represent how the superconducting magnet creates its magnetic field. The CT scan, similarly above, the image in the middle is going to be the CT scanner. The X-ray tube accelerates electrons and creates a beam around a patient. The gun then creates a high voltage that is deflected into the X-ray tube and is then detected by the detector once it has passed through the patients, and creates an image that is shown in the bottom left-hand corner. In the bottom right-hand corner, I used our physics models that we learned from class to show the X-ray machine and the waves traveling through the patient. Once it goes through the patient, it changes depending on the part of the body, and that change is picked up by an imaging system. This is related to the physics because we learned about magnetic fields and magnetic forces and how they are generated by moving charges or current in a wire, and how it generates a magnetic field and it exerts a force on our hydrogen atoms in our body, which actually create the image. In CT scans, it uses waves through X-ray, not necessarily oscillations, but that pertains to the same unit we learned, and electromagnetic radiation energy and wavelength to shoot at our tissues as they absorb different amounts of X-ray beams to create that image. I looked at a research that studied the difference between MRI and CT scan detection for brain bleeds, and this was done at 2 different stroke centers. So as you can see, here are images, one of a CT scan and one of an MRI scan, but this is the same brain. Here's the statistical data collected. On the left, you see whether the MRI picked up the hemorrhage or not, and whether the CT scan picked up the hemorrhage or not. In summary, this was the important findings. So there were 4 patients with acute hemorrhage that were detected on the MRI scan but missed on the CT scan. And then there were 52 patients that actually had chronic hemorrhaging that were all missed by the CT scan. So for a CT scan, it is really good for acute stroke symptoms to rule out hemorrhaging, although it's not the best for cerebral ischemia, which is cell death. And MRIs can detect both, but can be very difficult on patients' bodies, especially if they're elderly or have pre-existing health conditions. So with the use of MRI and CT scans, that is going to be expensive, yet necessary when creating the best treatment plan. So I created a MRI scan of a brain tumor. I painted this myself after studying images online. I also have known someone, so I was able to get some advice and see their own MRI scan of their brain. And I painted this hand draw and I mixed all of the colors myself. In conclusion, physics is found all around us between medicine, especially between diagnosing and at the molecular level of physiology. The MRI versus CT scan, both are great diagnostic tools. MRIs can be more precise, but not all of the patients are able to get them due to pre-existing health conditions. And for the CT scans, I learned about X-rays and how they're produced and how they're able to produce images of the body. Finally, in magnetism, I was able to learn how magnetic fields create and produce images of the body. Here are my sources, and thank you.